Hello, geometry students. Welcome to section 2-6 geometric proof. One of the most important and famous lessons in geometry ever is geometric proof. This lesson is extremely important because all the coming lessons rely on this section. Guys, geometry is not about finding a missing side length or about finding a missing angle measure, but it's about reasoning, it's about proving, it's about justifying any step you find. So guys, let's get started. This lesson objectives are write two-column proof. I'm going to explain what does it mean, the two-column proof. Let me get my red pen. Two-column proof, and prove geometric theorems by using deductive reasoning. When you write a proof, it is very important to justify each logical step with reason, justification, and reasoning. You can use symbols or abbreviations. We use them a lot in order to make a short two-column proof or justification, but they must be clear enough. They must be clear enough so anyone reads your proof will understand what they mean. Any proof is made up of three main parts. The first part is called hypothesis. Hypothesis, it means something we assume it's true. In order to find a final conclusion and reach our target, we need to use all definitions we studied, all postulates, properties, and theorems. Example number one, writing a justification. This is our first trial to write a two-column proof. Write a justification for each step. Given that angle A and angle B are supplementary and measure of angle A equals 45, find measure of angle B. Guys, we given a diagram. If you look at this diagram, we given two angles, angle A and angle B. We know that these two angles are supplementary. This is a given information. We need to underline the important information. This is the first given. They are supplementary. Do you know, guys, what does it mean two angles are supplementary? When two angles supplements each other, it means the sum of the two angles is equal to 180 degrees. Yes. And the measure of angle A equals 45. I can put 45. I can put that measurement. That's 45. This angle measures 45. And now our job is to find measure of angle B. I know, guys, you can find this mentally by subtracting 180 minus 45. It's going to be 135. But this is not the issue. The issue is how to prove this, how to write a complete two-column proof with reasons and statements. So let's get started. Guys, we're gonna list all our information in two columns. One column to the left, we're gonna call it the statement, the statements column. And the opposite column for the reasons, list of reasons. In step number one, if you want to write your first statement, you need to start by collecting all given information in one line. Guys, we given two pieces of information. We given that angle A and angle B are supplementary angles. So I can start writing my first statement in line number one. Angle A and angle B are supplementary angles. See, guys, I'm using a lot of abbreviations, but they are clear to understand. Another given is measure of angle A. Measure of angle A is equal to 45 degrees. So, guys, in step number one, my first statement, I collected all given information in one line, and the reason is very easy. What reason can be written? It's given. All this information are given. I didn't come up with a new thing in this line. Step number two. In step number two, guys, we need to start translating these facts, this given information, into useful statements. So what conclusion can be made from angle A and angle B are supplementary. What does it mean two angles are supplementary? We need to translate this into math, into equations. Yes, guys, you are correct. I can write measure of angle A plus measure of angle B is equal to 180 degrees. Now we started to speak the math language. And how do you know? How do you justify this? What is your reason? You wrote measure of angle A plus measure of angle B equals 180 degrees. How do you know about that? This is the definition of supplementary angles. So my justification or my reason, that's the definition of supplementary angles. Yes. What is the next step, guys? What information do we know and we didn't use yet? Yes, you are right. Measure of angle A equals 45. So the next step is direct substitution. So in step number 3, I'm going to insert 45 instead of measure of angle A, because I know measure of angle A is 45. It's given information. So 45 plus measure of angle B is equal to, that's the angle notation, is equal to 180. What is the reason? This is, yeah, substitution. That's the substitution property of equality. Yes, substitution property. Guys, now the next step is a very reasonable step. I'm going to subtract 45 from both sides. So minus 45 from both sides. How do I justify this? This is the subtraction property. Subtraction property of equality. And finally, guys, I can cross out this number and its opposite. So I have measure of angle B is alone is equal to, what is 180 minus 45? It's 135 degrees. So guys, how do I justify that? That's simply simplify. When I simplify, I get this answer. So that's your first beautiful 2-column proof. We call it 2-column proof because it's made up of 2 columns, 2 main columns, the left column for the statements and the right column for the reasons. We need to define something very important in geometry. Is called a theorem. Before we define the term postulate, you know what is postulate. Today we're going to talk about different, a concept is called theorem. You often use the word theorem in geometry. What does it mean? Theorem is a statement you can prove. Guys, did you recognize the difference between theorem and postulate? The postulate is a fact, but you can't prove it. You just use it by common sense. But theorem is a statement you can prove, and you prove it once, one time you prove it, and later you use it as a reason in later proofs. Let's get started with your first 2 theorems in geometry this year. Theorem 261, it's very easy to understand and it's very easy to use. Theorem 261 is talking about linear pair. We call it the linear pair theorem. So when you use it, guys, you use this title, you use this topic. So once you make your conclusion, you write the reason, linear pair theorem. Linear pair theorem says so. What is linear pair theorem? If 2 angles form a linear pair, you studied a linear pair, it's a relationship between 2 angles according to the position of the 2 angles, then they are supplementary. I'm not surprised. Everybody knows that any 2 angles that form a linear pair, they are supplementary. They add 180 degrees. Do you know the reason, guys? Because the non-common sides form a straight line. They are opposite rays. So any 2 angles form a linear pair, they are supplementary. So what is my hypothesis and what is my conclusion in this theorem, guys? My hypothesis is angle A and angle B form a linear pair. If 2 angles A and B form a linear pair, this is the first part of the theorem. This is the hypothesis of the theorem. What is the conclusion then? The conclusion is angle A and angle B are supplementary angles. Very easy to understand, guys. Another theorem, 262, we call it congruent supplements theorem. Before you studied a congruent complements theorem, this time you study congruent supplements theorem. If two angles are supplementary, to the same angle, both of them supplementary to the same angle, then the two angles are congruent. This is very similar to the transitive property of congruence. Guys, again, in math language, what is our hypothesis? Our hypothesis is angle 1 and angle 2 are supplementary, so they supplement each other. Another pair of angles, angle 2 and angle 3, they are also supplementary. So guys, did you notice that angle 2 is common between these two statements? So angle 2 supplements angle 1, angle 2 supplements angle 3 at the same time. So what is your conclusion? Conclusion is angle 1 and angle 3 must be congruent. That's very easy. And we call this angle congruent supplements theorem. So whenever you use it, you write this. Example number 2. In example number 2, we given a 2-column proof, and now we started to see a table. In order to organize our answer, it's preferred to collect all information in a nice table like this. The column to the left for the statements and the column to the right for the reasons. And as you see, guys, some statements and some reasons are missing, and our job is to fill in the blanks to complete the 2-column proof. So what is our problem? Our problem is we given XY is a line segment. This is a given information, and we given a diagram, and we can see that XY is a line segment. What do we need to prove? We need to prove that the line segment XY is congruent to itself. What do we call this property, guys? When something is congruent to itself, we call it, yes, symmetric property. Yes, the symmetric property. But we need to prove it. This time we need to prove it. So guys, we always start our 2-column proof that our first statement is always to the given information. So you write, well, whatever is given, and you justify that as given. And the reason is given to us, it's given. So what is given? You only given one information. XY is a line segment. This is the only information we know, guys, okay? And the reason is given. The second statement is given to us. It says XY equals XY. How do I justify this, guys? How do I justify this? Something is equal to itself. Yes, this is what property says. So this is the reflexive property. Reflexive property, that's, I said before, it's a symmetric. It is not symmetric, guys. Symmetric when A equals B, then B equals A. Sorry for that mistake. So it's reflexive property of equality. We have equation. Can you see? It's equation. So guys, what is our last statement? Our last statement is missing. But the reason is definition of congruent segments. Definition of congruent segments. So I have to write 2 congruent segments. And guys, the last statement is always whatever you want to prove. So the first statement is always the given information, and the last statement is always whatever you want to prove. So I can just copy from the prove line, prove that XY line segment XY is congruent to line segment XY. This is what I want to prove, and it always comes in the last statement, and the reason is definition of congruent segments. Yes, it's congruent to itself. This is the definition of congruent segments. 2 more theorems, guys. Theorem 263, we call it right angle congruence theorem. You need to memorize the title of the theorem, and you need to understand it, because later you're going to use it in 2-column proofs. You're going to provide the name of the theorem. Of course, you're not going to memorize the number of the theorem. You're not going to say by theorem 263. but if you remember the topic of the theorem, you can use it. So you can say by the right angle congruence theorem. By the right angle congruence theorem. What does it say, guys? It's very funny to me. It says all right angles are congruent. All right angles are congruent? Yes, because all of them measure 90 degrees. So what is our hypothesis? Angle A and angle B are right angles. What is the conclusion? The conclusion is angle A is congruent to angle B, of course, because they have the same measure, 90 degrees. Another theorem, guys, we call it congruent complements theorem. We studied before congruent supplements, now congruent complements. It's very similar to the congruent supplements theorem, and it's based on the transitive property. Do you remember transitive property, guys? When two things are congruent and another two things are congruent, but there is a bridge that connects both of them, then the first thing and the last thing are congruent. Take this theorem. If two angles are complementary, so the first statement, if two angles are complementary to the same angle, there is a third angle, and the first one and the second one, both of them are complementary to the third one. So what is the conclusion? Then, the word then is always followed by the conclusion of the theorem. Then the two angles are congruent. In math language, guys, we have two angles are complementary. Angle 1 and angle 2 are complementary. They complement each other. Another statement, angle 2 and angle 3 also are complementary. They complement each other. Guys, can you recognize the bridge, the connection between these two statements? There is something in common. Angle 2, yes. Angle 2 is in common. In the first statement, angle 2 complements angle 1. In the second statement, angle 2, the same angle, complements angle 3. So I can make my conclusion and say angle 1 and angle 3 are congruent. Yes, they are congruent. The last example in this section, guys, example number 3, writing a 2-column proof from a plan. We have a plan to the left and we need to write the 2-column proof. I think we given the reasons. We just need to write the statements of this 2-column proof. So we need to write the statements. Write a 2-column proof given that angle 1 and angle 2 are supplementary angles. Another given, angle 1 and angle 3 are congruent. What do we need to prove? Angle 3 and angle 2 are supplementary. To understand the problem, guys, you need to focus more on that diagram and read the given information. Angle 1 and angle 2, this angle and this angle are supplementary. What does it mean, supplementary, guys? How do I translate this into math? Yes, angle 1 and angle 2, they add up 180 degrees. Another given information, angle 1 and angle 3 are congruent. 1 and 3 are congruent. So what do we need, guys? Congruent, it means they have the same measure. What do we need? We need to prove angle 3 and angle 2 are also supplementary. So guys, how do I start that? We always start, our first statement is to collect all given information in one line. So I can just copy the given information. Angle 1 and angle 2 are supplementary. Angle 1 and angle 2 are supplementary angles. I can use some abbreviations to make it short. And another given information, guys, in the same line, angle 3 is congruent to angle 1. Sorry, I flipped that one, but still has the same meaning. If angle 1 congruent to angle 3 is congruent to angle 1. So all this is the given information. Okay, how do I translate this given information into mathematical statements? Let's start with the first given, guys. What does it mean to you if angle 1 and angle 2 are supplementary angles? Think about it. Yes, they add up 180 degrees. So my second statement is measure of angle 1, measure angle 1 plus measure of angle 2 is equal to 180 degrees. It's justified for us, guys. The reason is given. What reason can be written? Definition of supplementary angles. This is the definition of the supplementary angles. So guys, The other information we given that angle 1 and angle 3 are congruent. What is the benefit? What benefit can be made behind two angles are congruent? If they are congruent, they are equal. They have the same measure. So my third statement going to be measure of angle 1 is equal to measure of angle 3. If they are congruent, they are equal, and vice versa. So what's that? What is the reason? Definition of congruent angles. Definition of congruent angles. The reason for the third statement. So guys, now we need to make a connection between these two statements. I know measure of angle 1 plus measure of angle 2 equals 180. I know measure of angle 1 equals measure of angle 3. And guys, look at your final target. What is your ultimate goal? You need a connection between angle 3 and angle 2. So we don't need angle 1. Okay, angle 1 is fine, but we don't need it. So is it possible to substitute angle 1 in terms of angle 3 in the second statement? Yes, this is substitution property of equality. So if we go to the statement number 2 and we do substitution, if we replace this measure of angle 1 with measure of angle 3, plus measure of angle 2 is equal to 180. Guys, this is direct substitution from step number 3 into step number 2. I just replaced the measure of angle 1 by measure of angle 3. This is a substitution property of equality. And now guys, we are very close to whatever we want to prove. What do we need to prove? We need to prove that angle 3 and angle 2 are supplementary. Guys, statement number 4 says angle 3 plus angle 2 equals 180. This is exactly the definition of supplementary angle. So I can write whatever you want to prove comes as the last statement. So I can write angle 3 and angle 2 are supplementary angles. They are supplementary angles, and according to what? What is the reason? Definition of supplementary angles. If two angles add up 180, they are supplementary angles. So guys, congratulations, you have done the most important section in this year, geometric proof. Study well and see you in the next lesson. Bye.